Hello, I'm Isaac Ajao. Welcome to SoftData Analytics and Consultancy. I want to teach us how to carry out OLS regression analysis and interpretation using Stata. OLS regression analysis and interpretation using Stata. Here we go. Let's go to Stata. Now, on Stata, we have some inbuilt data we can make use for practice. System has some of this data by using the command system use directory. Will give us list of data we have. I want to make use of this auto data. So I can now say system use auto. This is what I want to use. Apply it. These are the variables. So these variables, we can quickly check them. The variables, how many observations? 74 observations. These are the prices of, these are pairs. These are pairs. These are their prices. These are their mileage. You can see. Now, for the sake of this training, I will carry out my analysis using this data. There are so many of them, I just choose to use this. Now, regression. You can go through statistics, linear model and related, this regression, linear regression. I can pick any of this, say statistics. You can see it here. You can see regression, diagnostics, and over 100. The one I want to use is this, but you can go through usage of the command regression, regress, or I just use reg. It's allowed. So the first variable you type here is your y. Y other one that follow the y are referred to as independent variable. That is the default in Stata. Price. The other ones can just copy them and right click, copy variable list. Go and drop them here. You can see reg, price, all of this, all to the last one, foreign. You enter. The result comes out. You can see this is use auto 2078 automobile data. This is the command. This is an over table. This is sum of square. This is degree of freedom. This mean square and number of observations 69. Then this is the p-value 0.00. So that shows how significant. Then we can see 1058. That's the overall regression model testing if at least one of the predictors is significantly related to the dependent variable price. If at least one of the predictors is significantly related to the dependent variable, that is it. And the high F value indicates that the model is a good fit. So if this one is high, it shows it's a very good fit. Then the F 0.00. So because it's less than 0.05, we reject null hypothesis. That's all coefficients are equal to 0. This indicates that the model is all statistically significant because it is far less than 0.05. Then the R square here 59.88 or 59.0.5989. This indicates approximately 59.89 of the variance in the price is explained by the model. So you can say 50, or you can even approximate it and say approximately 60% of the variance in the price is explained by the model or by the predictors. These are just third R square. It's always less than the R square. So this accounts for the number of predictors in the model and slightly lower than the R square value, suggesting that the model explains 52.97 of the variance in price when adjusting for the number of predictors. See, when you are adjusting for the number of predictors here, you go to that's why it's always less than this. Then the root MSE, that's mean square error, is standard deviation of the residuals. It's standard deviation of the residuals. Residuals are the errors. So they represent the average distance that observed values fall from the regression line. You know, when you plot your regression line, which we call best of line of best fit, those ones that are left over that are not that are not on the line of regression. So these are their mean square error. In there, this is the standard deviation of the residual. Now here, this is just the summarized result. This is detail now. Price is the response variable or dependent variable. The intercept here we have, you can see, this is intercept. You know, the way Stata presents its own results is different from other. It's different from Excel, it's different from R, it's different from Python. Your intercept will always come last. So that's 9789. That is under the coefficient. These are the coefficient estimate. We call them parameter estimate, regression coefficient, or coefficient estimate. They show the contribution of each of the indicators, the predictors to the price. You can see the mile per gallon now, which is MPG, is minus 21.8518. Now, this one can be interpreted as the additional for each additional mile per gallon. Additional mile per gallon, this is it. So the price is expected to decrease by 21.8 units. Or you approximate this one is minus 21.81. So for each additional mile per gallon, that's for the car we are estimating for. So it's expected the price is expected to decrease by 21.81 units. We normally use units here because we can't say it's in naira, we can't say in dollar, we can't say. So it means the contribution of MPG to the price is on the on the negative side. It has inverse relationship with the price. So that's what it means. If we hold all other variable constant, so this is going to be reduced by minus 21 units. Then, but the p-value shows that it's not significant because this is greater than 0.05. So in this case, the H naught is not going to be rejected. Now the same thing with this. So for each unit increase in the repair record, this repair record, see, about 184.79 unit. So it's going to increase by it because it's going to be increased by 184.79 units because it doesn't have negative. So anywhere we see negative, it's going to reduce. Whenever I see positive, it's going to increase it. At the same time, looking at the p value is still not up to 0.05. So it's not significant. Now the same thing goes with all of the remaining ones. Let me look at the one that is significant here. I think weight has significant relationship. And the contribution is 4.52. So every unit increase in the price, you can see what weight is contributing. It's going to contribute 4.5 units. You see, it's going to contribute 4.5 units. That's the. Then let's now check the p-value. P-value is 0.02. So, and that's a weight is significantly contributing to price. So it's a significant predictor of price. Another one, okay. All of the remaining one. This one is near significant, but it's not there. this one foreign 0.01. So and the coefficient is 334.84. So being a foreign car is associated with an increase in price by about 334.85 units. Is statistically significant with p-value of 0.01. So you can see it. So suggesting that being a foreign car is a significant predictor of price. So it's obvious also. Foreign car will always affect the price of car. So now, as a whole, we can summarize this. How do we summarize this? If you want to summarize the whole of this, we go back to this. See, you can summarize it. You can say the model is statistically significant as a whole. Total, at least, want to summarize this. You can say this model is statistically significant. Because of this is the overall status of the model. 0.000 is highly significant. Then significant predictors of car now, of car price, are just two. They include weight with p-value of 0.02 and foreign car 0.001. Then what about the goodness of the fit? Then you can look at it, R square 0.5989. Taking the adjusted R square, which is most preferred, that's 52.97, which explains 52.97 percentage of the variability in the car prices explained by the model. That is it. And which suggests a moderate fit, at least it's above 0.5. It's above 0.5. It's a moderate fit. So most of the variables, including LPG, Rep 78, trunk, and all of the rest, and GR ratio, are not statistically significant. They are not statistically significant predictor of car price at 5% significance level. You can also use this T. When you look at T, you see, the higher it is, the closer the significance. But before you can use this, we need to look at the value very well. Take the absolute value. You can see this is 3.2 and very high, higher than any of these one here. But the highest one is 3.48. So you can also choose this, but we prefer using p-value. So to write out this model, it's going to be a long one. But don't forget the significant one I just did. We have come to the end of this lecture. Next one, I'm going to show us how we predict. Thanks for listening.